Hey everybody, and welcome to chapter 12, which is all about decision making. So this is a fun chapter because a lot of the examples that we are going to go through are examples that I think are fun and interesting, and usually students really like them. But like some of the previous chapters we talked about, this is an area of cognitive psychology that is huge. Has this area, which is normally called JDM, which is judgment and decision making, has its own journals, has its own conferences, is a very big part of cognitive psychology. Another thing that's kind of interesting about this specific area is that we're going to see a lot of cross-pollination with other areas of psychology in decision making. I see decision making applied a lot, not just in social psychology, but also in industrial organizational psychology as well. And a lot sometimes in clinical psychology too. So there's lots of ground to cover. So with that said, this is one of the longer chapters. So what we're going to be talking about in this particular video are going to be these two items, introducing ourselves to the decision-making content, but also talking a little bit about Bayes' theorem. If you haven't heard of Bayes' theorem before, that's okay. We'll do a very quick crash course of it in this video. So here is another video, as I mentioned, some of the things that we're going to be talking about are very closely aligned with social psychology. So this video does a pretty good job, I think, of giving you kind of an idea of how those ideas marry. So in this case, we're talking about first impressions and how we think of people in this video, and it ties that into confirmation bias, which is a cognitive bias that we're going to talk about before the end of the chapter is over. If those things interest you, I have a lot of videos tagged at the very end of this PowerPoint that I highly recommend you check out too. All right, so before we get into any of that though, let's talk a little bit about flipping a coin. So you may have done this thought experiment before. Usually in statistics classes, you'll hear somebody bring it up to prove a point. And so let's walk through this together. Let's say that, and you can try to do the math if you want to. You flip a coin and it lands on heads. You flip the same coin, it lands on heads. You flip it again, it lands on heads. You flip it again, again, and again, and every single time it lands on heads. So you flipped it 6 times and it always lands on heads. Then you flip it one more time. Before you look at it, what is the likelihood that that coin, or the probability that coin has landed on heads? I'll let you think about it for a second. Most people, whenever they are trying to do this, they will try to do what they were taught in math about probabilities, which is that they will take 50%, they'll multiply it by 50%, and they'll multiply it by 50%, by 50%, by 50%, and so on until they get to the 7th flip. And that is a good guess, but it's actually not the best guess. The most accurate for what is the likelihood that this coin that you just flipped is going to land on heads is 50%. Now, whenever we talk about that, a lot of students don't like it because they feel like it's not intuitive, that this doesn't make sense. And that's exactly why I wanted to talk about it at the beginning of this chapter. Because if we were to apply perfect logic, we would find that the answer is 50%. If we were to go with our gut, the answer is going to be very different. Why? Because our gut is telling us that this information up here, that it landed on head 6 times, that information is important for this next decision. But in actuality, it's not. It's not like this history doesn't actually matter whenever you flip the coin next. Now, if we wanted to, we could rephrase this question very differently. And if we did rephrase it very differently, we could say, what is the likelihood of flipping 7 coins and it always landing on heads? That would be very different. That would not be 50%. But if we're talking about just this one coin flip, then the answer is 50%. But that doesn't come easily to us. This is something that causes us to scratch our heads. We want to work out the math. We want to think about it a little bit, or certainly I did whenever I first came along with this example. But it does a good job of illustrating how sometimes our gut leads us in the wrong direction when we're making decisions. So, because psychology is a science, It ought to be able to predict behavior. That is one of the key functions of any science. All sciences should try to strive for three goals. They should try to describe the phenomena that they study. They should try to explain the phenomena that they study, and they should try to predict and forecast the phenomena they are trying to study. And so, people who really don't like psychology will usually point to this piece about prediction, and they'll say, like, okay, sure, you can describe and you can explain these things, but you can't predict how someone's going to behave or what someone's going to do. And that's not exactly fair, because we are able to make lots of really close predictions. It's just that the anomalies are always the ones that stand out to us. So, why did so-and-so give away $1 million or whatever? Like, you wouldn't have predicted that. But I could have predicted that you're sitting in front of your computer, that you probably got another tab open, that you're browsing a little bit. You're listening to me, but you're maybe not watching the video. I'm able to predict those things, not because I am spying on you and your webcam is filming you, but simply because that's, it's an obvious guess. And so sometimes psychology is like that. So whenever we talk about human behavior, we are able to predict lots of human behavior. But the things that we get stuck on are when humans behave irrationally. That's whenever we find that we can't predict their behaviors, because we don't always behave rationally. So in cognitive psychology, there are two kind of variants of decision making and research in decision making. That is the decisions that we make rationally, which are called prescriptive models, and then we have decisions that are made irrationally, which are called descriptive models. So we're going to be looking at both of these in this chapter. Mostly, though, we're going to be looking at the second one. We're going to be looking at why people actually behave. Why do they behave irrationally and things like that. We're going to find that people do not always behave rationally and with logic and having understood the consequences of their action and made an informed decision about it and things like that. And honestly, that stuff is much more interesting to study in a lot of ways. But then here's the question. If you know that people will behave irrationally in certain contexts, can you then predict their irrational behavior? All right, so let's talk a little bit about Bayesian psychology, or Bayesian statistics is probably a better way to think about it. That Bayes' theorem is a mathematical statistical tool that is used very frequently these days. You may not have even talked about it whenever you took statistics. Whenever you took statistics, you probably talked a lot about frequentists models, which you probably didn't talk about it like that. You probably didn't have a word for it, but you probably used t-tests and ANOVAs, and maybe even regressions and things like that, which are all really great. But they're all one half of statistics. There's another half that is not really used as much, and it's kind of this popular thing now. Like, people are starting to use it more. It is, I'm not going to say a fad, but it is something that is gaining momentum in statistics and in that field. And so it's quite different than what you would expect based on, and I'm assuming that everyone here has taken a statistics class. I know that's not true, but if you haven't taken one, just hang tight. I'm almost done with the metaphor. That usually whenever we are talking about t-tests and ANOVAs, you remember that what we're really looking for is whether or not there is a difference between groups, right? You're looking at whether or not the variance in one group can't be explained by the variance in another group. Bayesian statistics is quite different. Instead of looking for differences like that, what you're doing is you're looking at likelihoods. So what is the likelihood of this happening versus the likelihood of this happening? So this really, in my opinion, this kind of broke into popular culture, that people started really thinking about it outside of academic circles whenever Nate Silver, who is a statistician who you may know from 538.com, which is a blog that is oftentimes politics, but looks at a lot of different things like sports and stuff like that too. Basically, he was able to perfectly predict every single electoral college vote in the 2012 election. In the 2008 election, he got all but one. In the 2016 election, he had the closest forecasts to the outcome to that. As you may remember, most people did not project Donald Trump to win that, but he was the closest to doing that. So he's been very successful in his predictions. And his methods are pretty simple. That all he really does is he applies Bayes' theorem. And he does that by looking at lots of political polling and then judging whether or not those political polls are trustworthy to begin with. And depending on how trustworthy they are, they're assigned values. The ones that are very trustworthy, that are very scientific, are given very high values. The ones that are very unreliable, that show problems with their validity and confounds, have very low values. And those things are weighted to give us prediction. So that's essentially what Bayes' theorem is. And and that's how we ought to predict things. That is essentially how we should be making decisions, which is that we look at evidence and then we come up with some estimate on how likely that evidence is to be true and how likely that evidence is going to shape the outcomes that we're looking for. So in other words, what is the probability of some event given everything that we know so far? That's essentially what Bayes' theorem is. So, this has been used not just in politics, but it's been used in lots of different fields. It's used a lot in sports betting, so people getting rich off of predicting sports outcomes. It's used a lot in meteorology and climate change science and disease forecasting and so many more things like earthquake predictions, legislation. It's used in lots and lots of different facets. So our perceptual systems are Bayesian in nature. What I just described up here about how we should be collecting evidence and then making a decision based on that evidence, that is exactly what our perceptual systems do, which is something you can learn more about if you take sensational perception next semester. I'll see you there. All right, so a couple of books in case you are interested in decision making. Here are three of them. These are three books that I recommend, probably in the order that I would recommend them. This was the first one. This is number 2, and this is number 3. So I'll go in these orders too. So this first book is Thinking Fast and Slow by Daniel Kahneman. This is a book that I used to assign my class, and I did because this guy Daniel Kahneman is pretty much one of the most influential researchers ever in decision making. He's done lots and lots of work in the field, changed a lot of cognitive psychology based on his research. And so this book it's like 500 pages, but very interesting, very engaging, lots of really cool examples too. But it is 500 pages, and believe it or not, students don't want to read a textbook and read a full book, 500-page book along with that, which is why we have research articles that are assigned throughout the semester instead of this book. But and all these, by the way, are aimed at casual audiences. You don't have to be a psychologist or a scientist by any means to get into this. This is something you could recommend your brother or mother. So the second one we have here is called Blink, and this is by Malcolm Gladwell. If you've heard of Malcolm Gladwell before, he is a reporter, he is a journalist who seems to write a lot about psychology. So a lot of people think that he's a psychologist, but he's not. He's not a researcher, he's just a journalist. Basically, his book here is about about how oftentimes our gut feeling, our intuition, our snap decisions can often be our best decision makings in many contexts. And then finally we have Nate Silver, who I referenced in the previous slide. Nate Silver wrote a book about Bayesian statistics called The Signal and the Noise, and it's pretty good. It's not the best, probably. The book is probably about 6 chapters too long, but it's an interesting read. All right, so let's talk a little bit about Bayes' theorem. Now, I'm not going to ask you to calculate these things on an exam, but I do want you to know the kind of the components of Bayes' theorem. So we have these three pieces. I'm going to start over here actually at the very end with what's called the posterior probability. The posterior probability is essentially the outcome that you're looking for. What is the probability of this event happening? Or in terms of our decision-making perspective, what is the probability that this information is true given what we know? So that is ultimately what we are trying to find using this branch of statistics. The second piece then I want to talk about is going to be this one, the prior probability. This is what is the probability that this information is true before you look at the evidence. Oftentimes it's probably going to be 50-50, right? Not necessarily, but most times. So the prior probability is kind of like your baseline. It is your base rate before you look at any information about what the likelihood is of this information being true. And then finally we have the conditional probability. And the conditional probability is the likelihood that some evidence that you're using is true. So basically, just to recap, what we are doing when we are applying Bayes' theorem is we're looking at the base rates. We're looking at what is the common likely rate of this event happening or this information being true. Then we're going to look at some evidence, and we're going to say, okay, what is the likelihood that this evidence is true? How much can I trust this evidence? Is this good, worthwhile, trustworthy evidence, or is it flimsy, So you're going to use these two together to get this third piece, which is going to be the posterior probability, which is the likelihood that the information that you have is true given everything you know, which means looking at the prior probability and looking at the conditional probability together. This is a fancy way of expressing that. So the probability here, the P stands for probability, and if you're not familiar with the way these things are written out, this line right here means given. So what's the probability of this hypothesis given the evidence? What's the probability of the evidence? What's the probability, the prior probability of the hypothesis? And what is the probability of the evidence given the hypothesis? You factor all those things together to give you the posterior probability. Don't worry about it. I'm just showing you to give you an idea. I'm not going to ask you to calculate that for an exam. But let's apply this to see how it looks in the real world. Let's say you want to decide or you want to find out whether or not Google will hire you. And so we have a couple pieces of information. We know the likelihoods of people who are hired by Google versus people who are not hired by Google. So we know that that of everybody who applies to Google, that 1% are able to get a job there, and that 99% are not able to get a job there. So very, very big disparity, right? 1% versus 99%. So then we're also going to look at this other piece of evidence, which is what are the likelihoods of getting hired when you do and do not have an interview. And so what we're looking at here, and both of these add up to 100, as you can see, that the probability that you got an interview and you were hired by Google is 80%, versus that you got an interview and were not hired by Google, that overall 9.6% of people did get an interview. All right, so if you were looking at this and somebody during Thanksgiving dinner is asking you, hey, how's the major going? You're gonna get a job anytime soon. How do you know what to tell them? Let's say that you did get a job, that you did get an interview at Google. What do you tell them? Do you tell them that it's likely or that it's not likely, right? Because we have kind of two things to worry about here. We might just look at this piece right here, right? If we're just looking at this, it looks like if you got an interview, that you're good, right? But it's important to consider this piece right here, this 1%. That makes a huge difference. So if we apply Bayes' theorem, what we're essentially going to find is that the probability of getting an interview and getting a job is actually closer to 7.76%. So it's still not super likely. It's just that of the people that were hired by Google, almost all of them did get the interview. But that doesn't mean that if you got an interview, you're more likely to get hired. In fact, it still means that it's still going to be hard for you to, right? Because almost 10% of this 90% applied, got an interview, and were not hired. All right, so if you have any questions about that, let me know. I know it can be kind of confusing. We're going to move forward into our next video, which is all about probabilistic judgment. See you there. Bye.